Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance, and today we are looking at reactants and products, specifically how to determine reactants and products given masses. So, our first example is given the balanced equation, if there is 658 grams of C2H6 that is burned, what is the mass of the water produced? So the thing we have to recognize in this is that they're giving us the mass of a reactant and asking for a mass of the product. The first thing we're going to want to do is to calculate the molecular mass of both of these molecules. So let's start with mass of H2O, which would equal 2 times 1.008 grams per mole, plus 16 grams per mole. That's 2 hydrogens, 1 oxygen, and that gets us 18.02 grams per mole. So that's our mass of the molecule of water. The other molecular mass we'll want to get is for C2H6. Which is 2 times 12.01 grams per mole, plus 6 times 1.008 grams per mole, which gives us 30.07 grams per mole. So that's the bare necessities of what we need. Now we can create a dimensional analysis using those values that can get us to the answer of what we're looking for. It's very simple. Start off with what you're given. We're given the mass. So 658 grams C2H6 times 1 mole over 30.07 grams will get us the number of moles of C2H6. So that gets us 21.9 moles of ethane. Then we're going to take that moles that we calculated of the ethane and put it down here, 21.9 moles. We need to do a conversion of the number of moles of ethane versus water. So when we're doing that, we're doing a relation using the balanced equation. So we need to cancel out moles of ethane, C2H6. So we're going to put the number of moles of ethane in the balanced equation at the bottom of this division. So it would be 2 moles ethane and on the top we'll put the number of moles of water. So there are 6 moles of H2O. This will get us the number of moles of water produced per every cycle using however much ethane we have burned, which happens to be 65.7 moles. That's moles of water, H2O. The last part of our dimensional analysis is to take this value, 65.7 moles, and we're going to bring it back over to its mass. So we're given that 18.02 grams per mole is the molecular mass of water. So we need to put our mass at the top, 18.02 grams, and 1 mole at the bottom. And that gets us 1.18 times 10 to the third grams of H2O. You'll note, whenever you do dimensional analysis, that the grams and grams cancel each other out on that one, and you're left with moles. The moles and moles cancel out of ethane, and you're left with moles of water. And then the moles of water cancel out with the moles underneath for the molecular mass of water, and that leaves you with grams, which is exactly what you wanted. So just remember, whenever you're doing dimensional analysis, to make sure your units cancel out in addition to finding the result. If your units don't cancel out properly, then chances are you've done it incorrectly. Let's look at another example. Given the balanced equation of ethane plus oxygen yields CO2 and water, it's the same equation that we just looked at, but it says we have 8.98 grams of CO2 that is produced. So it's what is the mass of oxygen consumed in the combustion. Again, we'll need to get our molecular masses. In this case, we need the mass of CO2 and the mass of O2. Well, the mass of CO2 is just 16 times 2, that's 2 oxygens, and 1 carbon, which is 12.01. So let's write that out. 12.01 grams per mole plus 2 times 16.00 grams per mole. And that gets us 44.01 grams per mole. And for the mass of oxygen, it's just 2 times 16.00 grams per mole, which gives us 32.00 grams per mole for the molecule. And next we set up our dimensional analysis. So we'll start by, all the way over here, writing out 8.98 grams, and that's of CO2, so CO2, times 1 mole over 44.01 grams, which is the molecular mass of carbon dioxide manipulated to fit our purposes with dimensional analysis, times 7 moles of oxygen, diatomic oxygen, over 4 moles of CO2, I got those numbers from the chemical equation. There are 7 moles of diatomic oxygen and 4 moles of carbon dioxide. And then multiply that by 32.00 grams over 1 mole of O2. Let's look at those units cancel out. We got grams of CO2 cancels with grams of CO2. We have moles of CO2 cancel with moles of CO2. Moles of diatomic oxygen cancel with moles of diatomic oxygen. And we're left with grams of diatomic oxygen. So when you do this calculation out, you know that you have the correct units. So there's unless you do an arithmetic error, there's a high likelihood that you're going to have the correct answer. When you do all this out, you find that 22.8 grams of O2 are consumed in this process.